Hello, welcome once again. Now, for any automotive schematic or electrical schematic, there's always symbols and components. Now, for example, for automotive, in this one, we have ignition switch. We have the component over here. We have a temperature light, a bulb. Now, in several positions, ignition switch is obviously applied. Okay? Now, as is referred to, in this position over here, from here, we have a connection to where? One side of B goes to the battery, which is the positive. The other side of C goes to where? From the ignition switch goes to a bulb, which goes to a temperature sending switch. Now, the point I want to make, as I was asked, the connections of wiring is not specified what type of wire to be used. This could be hard wire, this could be copper wiring, could be any type of wiring. Let's look at the wiring. Now, as you can see over here, obviously, this is hard wire. Okay? So the harness wiring in your car is composed of hard wiring. Okay? This can melt from heat. Let's say if it hits a hot surface on the engine or somewhere. Remember, the hot surface is all over. Hoses are hot. Everything is hot. High pressure is hot. So this can melt, or this can break, or it can be chewed up by rodents in your car, which they love to nibble on or bite on, especially if you go up in the woods, in the Poconos and woods. Animals will get into your car and they'll start chewing on hard wire. Okay, so all it tells you is let's make a connection from positive battery to B terminal of the ignition switch. Here's another type of wiring that you have in all these computer modules in your car. Okay, here's another type of wiring. To look at the wiring, this is not hard wiring, as you can see. The traces, this is called the trace, from this component, D8, okay, the cathode, the anode, from D8, which is a diode. You can see this line over here going, extending all the way over here to this part. This is called another type of trace, or copper tracing, or a wiring, a connection, an electrical connection from one point of a diode to another point that goes to where? Goes to the other side of the board. These are type of boards that you have in automotive, computer boards, where you have components on both sides. One side here, the bottom of it, the bottom layer, as it's referred to, has the components. These are capacitors, electrolytic capacitors. You see the positive over here? This means that this band over here is the positive. You see the letter C? That means it is a capacitor. You see the letter R? You see the letter R97? You see this? This is a resistor with the value on it. Okay? It's not through hole. It actually has the value printed on it. So the schematic just tells us make a connection from one point to another point. Here's a connection, as we just specified. Here's another connection from here to here. Notice the width. The width got bigger, but the length got smaller. Look at this one. The length is longer. The width is smaller. The schematic does not specify you how to do that. This is pure engineering. The width and the length of it is pure engineering design. The schematic just tells you once more, I want you to make a connection from here to here. It could be a printed circuit board. It could be hard wiring as this. It could be copper wiring. It could be anything that you want from here to here also. Okay? Looking at the boards, at these computer boards, as I specified a couple of times, this is what you're dealing with in automotive and every electronic gadget out there. Of the chips, of these small components over here. See these small components? Imagine you're driving 80 miles an hour, 90 miles an hour. You're hitting potholes, bumps. You think that these microprocessors RAM chips, ROM chips, ROM chips can take that abuse. These little pads is the only thing that's holding this pin, making the connection. Once this comes off from here, that's it. The electrical connection is open. Now imagine, as I said, you're speeding and speeding and speeding. This is being hit all the time from vibration. So that's what's happening with these boards. Again, the proper connection is your choice. The choice of engineering, designing what they want to use as the connection. It only tells you, I want you to make a connection from here to here. Okay? I want you to make a connection from here to here. The only thing you'll see in automotive schematics, it'll tell you the color of the wire. That's if you have hard wiring. This is a red wire. What about if you have this? There is no color of the wiring, correct? It's all the same traces. So you have a trace, a connection from R55 to this connector, right? You have another one from here to here. Now you notice when this is soldered, as you see it is upright, it is making a good connection. Over time, look what happens. Look at the component. You see how it is making a connection, but it is not straight. Okay? Over time, that small little resistor will be off the pad and lifted off the pad, because it is not the greatest of connection over here. See this? You see how it is soldered? And you see this? Even though it's solder, it is not perfectly straight and the best placement of that component like that. So all these on these printed circuit boards, TCMs, transmission control modules, for electronic brake modules, for radio receiver has a module, air conditioning has a module, nothing doesn't have a module, right? So this is what we're up against. 2 layers, 1 layer on top, as I specified in a couple of videos. A layer of components on the top. In between, there's a sandwich. There's more connectors in between. It's like a sandwich. You can't see it, but it's in there. Making connections from here to the bottom. This might well be 3 or 4 layer boards. So you can imagine what's going on in between. So therefore, when you look at schematic, remember the components, the connection, the symbols. Okay? Looking at a fuse. If the fuse is blown, and I've shown you so many fuses, you're doing a visual, and many people do a visual and say, okay, you know what? Inside, the elements are melted. This is open. This is good. I do not trust this, and I do not trust my eyesight in doing a visual. I always take an ohm meter, and I measure here at the blades over here, at these blades over here. Then I know for sure if it's good or bad. You can either do it on top with ohm meter or on the bottom from here to here. How much should you measure? 0 ohms over here. If you measure anything but 0 ohms on a fuse, let's say 100 ohms, 1,000 ohms, disregard that fuse. So the load rating is 20 amps. It's always on the fuse itself, the rating of that fuse. It doesn't matter what type of fuse, it has to tell you the rating that it has. Okay? One more thing that, as I specified, color codes in automotive fuses. They all have a color code related to 20 amps, 30 amps is a different color, 40 amps is a different color. They're all different color. They are color coded, just like the resistors were on through-hole years and years ago. So anyway, I hope this helped a little. Like I said, don't trust your eyesight on making a visual on components and on fuses. You will misdiagnose. Just do an ohm meter test, not just a voltmeter test of 12 volts here, 0, it's blown. always do a no meter test. So please refer to my channel, Joe Electronic Schematics for Auto, where you see more videos, and Automotive Electronic Schematics by Joseph. And thank you, and please subscribe.